Okay, so if you were doing this one here, then in your parallel part, so that shows you the start of the parallel section there. That shows you the end of the parallel section there. And you see in one of these branches you've got one resistor, but in the other branch you've got two resistors in series. So they're in series because they're in one current path. So you would take an RS, if you like, first. And make that for R3 plus R4. So that'd be the 12 plus the 8, giving you 20 ohms. And that's a kind of equivalent of that. So now you've turned that parallel section from being like that to being like that. So that's still R2 with the 20 ohms. And this is now this RS, this equivalent of those two, giving you the 20. So it's this part of the circuit here. That has gone from that to that. Yeah? So these two are in series, but they're inside a parallel section. So the parallel section is between those two junctions, isn't it? So you've taken those two in series and replaced them by a resistor that we're calling RS. Looks a wee bit like R5, but that's meant to be RS of 20 ohms. Because it's just the 12 ohms for the first one, plus the 8 ohms for the second one, giving you that RS. Nothing else in the circuit has changed at that point, but that's an equivalent circuit. When you go to do the voltage across that part there, yes, you will need to separate them again when you go to do the voltage. But at the moment, if you're just working on RT, that would kind of be your first step. Then your next step would be to get your RP. And RP would then be these two in parallel. That'd be your RP. So when you take these RS and R2, you put them in parallel, using that parallel method, you should get your 10 ohms. And then when you look at this equivalent circuit, you see there's one current path. So when you go into your kind of final answer, your R total, as if there's just one resistor in the circuit. Because there's only one current path, you take R1 and RP as being in series, and that'll get you your R total. And that gets you 18 ohms. Okay, so to get your IS from this, move that up a wee minute, use this page. So to get IS, you're just using your straight Ohm's law. So your IS is your supply voltage divided by your total resistance. So it's that 40 from your original circuit divided by 18. 2.2222. Now, when you look at your circuit, you're really looking at this circuit here to do your current divider. So this current here coming out of here, that's your IS, isn't it? And it's your IS that comes up and hits that junction here. So to get your I1, which is the one that goes through RS, or this R3 and R4 together, the current you're dividing is IS. The resistance in the opposite branch is your R2, and then the two branches added together are R2 plus RS. Right, so it's always the current that you're dividing first. So it's your 2.222 times 20 over 40. So it must be 1.111 amps. Amps, not ohms. And then the same idea for when you go and do I2 is IS times, and the opposite branch from your I2, which is coming down here, RS is on the top, over R2 plus RS. Now they are the same value of resistor in each branch, so you would expect half to go through each branch, and that's exactly what we've got from our divider. Half through each branch. Yes, because I've called it R series, so I've called it R series has been the equivalent of R3 and R4. So once you've got these currents, the next step is to go and look at the voltage across all the resistors using voltage division. Okay, so the first circuit you would use, voltage division is always on series circuits. So you would look at this circuit here is to use your voltage divider. So that'd be your first voltage divider. So if you wanted your V across resistor 1, whatever you call it, VR1, then it would be VS times resistor 1 over resistor 1 plus resistor parallel. So it'd be your 40 times 8 over 8 plus 20. RP. RP is 10. Sorry, I can't even read my own diagram. RP is 10, it's 10 there. So that gets you 17.78. And then your voltage resistor parallel is VS you're dividing again, but it's RP in the top this time. So it's 40 times 10 over 8 plus 10. And these two should add up to give you 40, so that'll be a quick check that you'll do afterwards. $22.22, which when added to 17.78, that does give you 40, so that's fine. So that's you now. When you've got that VRP, you've got the voltage here across this resistor, and you've got the voltage here across this parallel part and across this parallel part. So now you know the voltage across R2. So that VRP is the same as the voltage across R2. Well, the question's asking you to do voltage across all resistors by voltage division. It would give you the same answer, but it's a different technique. And usually when you do your assessments when you get to HN level, it's more about demonstrating a technique than just getting the right answer. So now when you go on, you also know that you've got the voltage there, that's the voltage across RP. So your voltage across RP was the same as the voltage across R2, and it's the same as the voltage across this whole series part. So it's the same as the voltage across R2 is the same as the voltage across R3 plus the voltage across R4. So we can do another voltage divider on that. So that voltage there across that section is the same as that voltage there across that section. So to get our voltage across R3, we're going to divide our VRP or your VR2 or whatever you want to call it at that section. But this voltage here across the parallel part. Then you're going to do R3 over R3 plus R4. So the voltage you're going to divide to 22.22. Resistor 3 is 12. And resistor 3 plus resistor 4 is 12 plus 8. Getting you 13.33 volts. And you use a very similar method to get the next one for VR4. Again, from this, we know it's VR2 that you're dividing, or VRP, because these are both the same. And And this will get you the other part of the 22.22. And you should get 8.89 volts for that. And that's your two dividers. So you've divided your voltage here in this circuit, and then the voltage across the parallel part, you've divided again to get the voltage across these two resistors. The voltage you're dividing is 22.22, so these two answers should add up to give you 22.22. And these two answers here should add up to give you the 40.